This video is a quick introduction to gases, chapter 10, out of the Brown-LeMay text, and to get you used to using some video casts to preview and learn some material about the gas laws chapter. First of all, gases are made of particles that are spread out far from one another. And gases, particles are tiny, 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 and we'll actually talk later in the chapter about how small and insignificant we actually consider them somewhat to be. But never forget that they are made of small particles as well. There are four main things that describe gases: the pressure of a gas, the temperature of a gas, the volume of a gas, and the volume that we assume the gas actually occupies, and the amount of a gas. The amount of a substance in chemistry, we usually use moles to describe the number of molecules or particles of a gas. Now, pressure is usually measured in a number of different units throughout the world. Here in chemistry, we'll use things like atmospheres. We'll use symbolized ATM. We will use kilopascals, symbolized kPa. We'll also use millimeters of mercury, or sometimes called torr, symbolized mmHg or torr. Now, occasionally you'll see it as pounds per square inch. It's a common everyday use here in America. And every once in a while you'll see some other measurement as well. These are all related to one another and all used to measure pressure. 1 atmosphere is equal to 101.3 kilopascals, which is equal to 760 millimeters of mercury, or 760 torr, which is equal to 14.7 psi, by the way. A lot of these relationships are given to you in the back cover of your textbook, or easily looked up on Google or somewhere else. Temperature in gases is described using the Kelvin temperature scale. And if you remember, the Kelvin temperature scale is equal to the Celsius scale by taking 273 Kelvin and adding it to your degrees Celsius. And this will give you your Kelvin temperature. Kelvin is an absolute temperature scale, meaning that 0 Kelvin is actually absolute zero. It's where all molecular motion would actually stop. Volume is measured in liters or in milliliters. Occasionally you'll see it in some other measurement, but the conversions are probably on the back cover of your textbook. And moles, of course, is measured in moles.